So we are on page 407 on check your understanding number 3. All right, I'll read it to us. So it says, write a linear system to model this situation. Wayne received and sent 60 text messages on his cell phone in one weekend. I wonder if I send 60. Maybe. Okay, so then it says he sent 10 more messages than he received. All right, maybe somebody's ghosting him. I don't know. All right, so let's write a linear system. Remember I told you the other day that when we're writing linear systems, we want to start with a let statement. Okay, so that lets everyone know what your variables represent. So in this case, let's let S, and again, you can pick whatever variable makes sense for you, equal our number of text messages sent. Okay, so I picked S because sent starts with S, okay? And then let's do our number of text messages received. All right, so what information do we have? It says that he received and sent 60 text messages on his cell phone. Okay, so the total when he sent and received, sent plus received equals 60. Okay, that one's always the easy one I find to get. Then the second one says he sent 10 more messages than he received. So take the bigger one, he sent more. Okay, so sent minus received equals 10. Okay, he sent more, so put the bigger one first, and if you subtract what he received, it would be 10. Okay, that's great. So we have our two linear equations to make up our system. Then it says, graph the linear system, solve this problem. All right, let's go ahead and do that. So different ways you can do this. I'm going to go with, for this one, finding my x and my y intercepts. I think I'll do that. All right, so let's plug in, we know, I'll just remind you that our y-intercept is when x is 0, and our x is when y is 0, okay? So if I put in 0 for my, you can call it x or r, whatever you want it to be. Let's put a 0 in here. We'd have 0 plus r is 60, so r equals 60, okay? And then if I put a 0 in for this, okay, 0, s plus 0 equals 60, s is 60. So look at that. They both have the same intercept, okay? Over there. Now, this doesn't really tell us what should be our independent and dependent variable in this case. And it actually doesn't really matter whatever we choose to be either one. When we graph it, we'll still get the correct answer. So why don't we go ahead and call our received here and sent here. Again, if you do it the opposite way, it's totally fine. Okay, so in this case, we could graph this. 60, either one will be 60, won't it? 60, okay, so this one will look something like that. All right, let's go ahead and look at this one, and let's do the same thing. Let's put 0 in for s, so negative r would be 10, r would be negative 10, okay? And if we put in 0 for r, s minus 0 equals 10, so s would be 10. Okay, so r, negative 10, so we've got that one. Negative 10, I'll say is around here. S is 10. So something like that, okay? So again, we found this spot right here, which would be our solution. So according to the book, it looks like it was, so if we look at what was the received, 25, R is 25, and S is 35. And that looks about right from my graph, okay? My R looks a little bit shorter than this, okay? So again, this you check by on your graph, something like that. And my point on this one would be 25, 35. Yours might look different if you chose S to be here and R here, but again, you'll still get the same answer, it'll just be backwards. So at the end, you should always do a sentence. So something like, what's the guy's name? Wayne, okay? Wayne sent, we want to know our S, 35 messages and received 25, right? And you can see really quickly, oh yeah, that adds up to 60 like we said. The sent is 10 more than the received, so very good. Okay, so let's go ahead and erase that. So that was our check your understanding number 3, 7.2. Now I do have a short assignment for you. I would like you to pass into me whatever way is easiest for you. On page 410, I want you to do number 12 and 13, okay, to be passed in. Feel free to check your answers with the back book. I do need to see your work done on these. Obviously, I can't give you full marks for just copying from the book. So please do 410, number 12 and 13. That will be your assignment. And while we're here, let's do one more together. If you want to watch this, you can. If not, you feel free to stop the video now. But we're going to go over number 10 and 11 together. Okay, this will help you out. This will especially help you with those assigned questions. Okay, so number 10 on page 410 says, the area of Stanley Park in Vancouver is 391 hectares. The forested area is 141 hectares more than the rest of the park. What is the area of each part of the park? Okay, I always like to look at that last sentence for clues on what my variables will be. It's saying to me, what is the area of each part of the park? And then I look ahead and said, oh yeah, they talked about forested and the rest of the park. So there's a forested and a non-forested, the rest of the park. All right, so let's go ahead and do our let statement. We should always start with that. So let's let F equal the forested part of the park. Okay, and I'm just going to use R for the rest of the park. You could have used U for unforested, whatever. So we've got F and R for rest of the park. All right, so from that, it told us that the forested, that there's 391 hectares, right? So the forested part plus the rest of the park does equal that 391, okay? So a lot of these problems are going to have something like that. It'll give you a total, and you just need to define your two variables. Then it told us that the forested area is 141 hectares more than the rest of the park. Okay, so the forested part, again, the bigger, you took away the rest of the park, there'd be 141 more. Okay, so always put the bigger when they say more. Put that first. Okay, so we have our two equations here. And then it says to solve the related problem. Indicate whether your solution is exact or approximate. So I'm not going to go and do this graph for us right now. We've done a couple of those already. But again, you could put this into slope-intercept form. You could find the x and the y coordinates and go from there, the intercepts, and do that. You could come up with your own table values by just substituting in random numbers. And when it says to you, is it exact or approximate? It's exact if on your graph you can see that it's clearly going through this certain point, like an exact number. But if it's somewhere, for example, if it was like this and this wasn't quite on an exact spot, and you have to kind of guess or do your best estimate, then it's called approximate. So just, you'll see that as you go along. Okay, so that's for number 10. And we'll do number 11. All right, number 11. Any volunteers to read? No? All right. In the American Hockey League, a team gets 2 points for a win and 1 point for an overtime loss. In the 2008-2009 regular season, the Manitoba Moose had 107 points. They had 43 more wins than overtime losses. How many wins and how many overtime losses did the team have? All right, again, look at that last sentence for clues for what you're going to use for your let statement. Okay, so let's go ahead and do that. Let's let W represent our number of wins. Okay, You'll notice sometimes I'm a little lazy, like putting a number. You can write out the word number, right? It doesn't matter to me. All right, and then I'm going to do L equal the number of overtime losses. Overtime losses. Okay, great. So it told us, sorry about that, just dropped a ping pong paddle. I am in my ping pong room. It said here, a team gets 2 points for a win and 1 for the other. All right, very good. And they had 107 points. Okay, so 107 points. And they told us you get 2 points for a win. So I'm going to say 2 points times every win plus, how many points did they get for an overtime loss? 1. So I could write the 1 if I wanted, times the loss. You don't need to put the 1 if you don't want. And when you multiply the wins plus the losses, and you add them up, okay, you got 107 points. Okay, so for example, they could have had, well, there's different things you could have, but you'd get up to 107. Okay, so the second part said they had 43 more wins, okay, so the bigger thing, they won more, than overtime losses. All right, so my wins, subtract my losses, okay, would be 43, right? Because there are 43 more wins than losses. Okay, so that helps you kind of get your two equations. So from there, again, you're going to do a graph, and you'll see where those two intersect one another, and that point will be your answer. And you do need to say if it's approximate or exact, and you'll be able to tell, is this an exact point that I'm looking at, or do I have to kind of estimate a little bit, and then it would be approximate. All right, so that should help you, those two. The trickiest part for you guys at this point is probably getting your system of equation down. So again, just read that problem, see what makes sense. Always start with your let statement and go from there. All right, again, if you're having trouble, need any extra help, please be in touch. I'd be more than happy to help you. Otherwise, your assignment is due tomorrow, Thursday. And just if you ever need more time too, if you're just finding it overwhelmed or you have other things going, just message me and we can talk about that. But I hope you guys have a wonderful weekend.